starting.
Alright, so go ahead and take the time to pause the video right now to look over the problem.
One thing that must be noted is this is one string. This is the force. This is one string only.
Okay. So here we have the force diagram. You see the force of gravity is straight down, so you could say that it's F of G, Y. And then we have here the force of tension in the Y direction. Here we have the total force of tension. And here we have the force of tension in the X direction. One more thing to note is that there's a 70-degree angle right here. Oh, right, the alternative understanding. The alternative understanding is here in that the force of Y equals the force of tension minus the force of gravity, which is incorrect. You'd know this because the force in the Y direction clearly is not the same as force of tension.
Object stays at rest, so acceleration in the y direction and acceleration in the x direction are both zero. Newton's second law is applied because it is in an inertial reference frame. The summation of the forces in the y direction is equal to the y component of the tension force minus force of gravity, which is equal to the mass times acceleration in the y direction, which is equal to zero. Tension of the y component of the force of tension minus the mass times gravity is equal to zero. The y component of the force of tension is equal to mass times gravity. Mass times gravity is equal to 10 kilograms multiplied by 9.8 meters per second squared. The y component of the force of tension is therefore equal to 98 newtons.
Using the y component of the force of tension that we just found, we can now find the force of tension through the Pythagorean trig theorem. As you can see, we have this triangle, and with it we can use the cosine trig function. So here we have y component of force of tension over force of tension, and switching around the variables and knowing the value of the y component of force of tension, we can solve for the force of tension, which is rounded up to be 287 newtons.
So we know from this part of the questions that F of Ty is equal to F of G, which is mass times gravity, Earth gravity. F of G will not change because the mass of the bending stays the same regardless if you move the two ends of the rope or not. So when F of G does not change, Fty will not change also. So we get this equation from the above equations. To find F of T, F of Ty divided by F of T is equal to cosine of theta, which is 70 in this case. Here, if we change the value of theta, we have to make the whole value of cosine theta bigger in order to decrease the F of tension. You can see here when we move the two ends of the rope closer, we make a new angle. This new angle is smaller than the original angle, which is 70 degrees. This small new angle gonna increase the value of cosine of theta. When this value increase, then F of T will decrease, which means that moving the two ends of the ropes closer will decrease the force of tension, and you don't have to worry about the string gonna break and the painting gonna fall when the force of tension is too much.